Here's an example of dividing polynomials. The top polynomial is your dividend polynomial. The bottom one is the divisor. So with polynomial or long division, you put the dividend polynomial underneath. So x cubed minus 6x squared plus 7x minus 2. That goes underneath your division sign. The divisor is the bottom one, goes out front. So when you start the procedure, and you were asking about the answers up top, how do you know they're positive or negative? So the first thing you do, you say how many times does x go into x cubed? And if you're having trouble figuring that out, it's how many times is x, that's always the bottom part, go into x cubed. What's inside goes on top, and it's a little division problem. Alright, x goes into x cubed, x squared times. Right, so that's the first part of your answer. I always put it up above the other x squared term, but it really doesn't matter where you put it up here. Some people like to put it way up front. Doesn't matter. Alright, once you get that first part of your answer, you multiply back. X squared times x is x cubed. Then x squared times a negative 1 is negative x squared. Alright, once you multiply back, you actually subtract, but I like to change signs and then add straight down. These first two terms should always cancel. That's a positive x cubed and a negative x cubed. Those cancel. So again, we're just adding straight down. Negative 6x squared plus x squared leaves me with a negative 5x squared. This is why I chose this example. Alright, let's bring down the plus 7x so you can see how this first part of the answer was a positive x squared, but watch what happens with the next one. Once you bring that next term down, you go again and you say how many times does x now go into a negative 5x squared. So here's the question you're asking yourself now. How many times does x go into a negative 5x squared? If this term down here that you're trying to divide into, if that's negative, then your answer up here is going to be negative. That's really the answer to your question. So over here, how many times does that go? The negative 5 is still there, and an x. It'll cancel. You'll be left with an x there. Right, that's the next part of the answer, a minus 5x. Alright, so when you take negative 5x times x, you're going to get a negative 5x squared. When you take negative 5x times a negative 1, you will get a plus 5x. Alright, we multiplied back by both of those terms in my divisor polynomial. We wrote them both down here. When you draw your line, yes, you're subtracting, but I like to change signs so that I can add straight down. Definition of subtracting is adding the opposite. So I like to change signs and add. That's why these will cancel out. Then a plus 7x minus or plus a negative 5x leaves me with 2x, which is positive. Alright, let's bring that last negative 2 down, and then you go again, you say how many times does x go into 2x this time? Goes in there 2 times, and that's positive because this 2x right here is positive. So it's a plus 2. Alright, let's multiply back and see where we are. 2 times x is 2x, and 2 times a negative 1 is a negative 2. Right, if you change signs and add, you'll have nothing left. So this is your answer. Didn't have a remainder, and if you have a number left down here, you can always put plus whatever your remainder is divided by this divisor, the x minus 1 out front. But if you don't have a remainder, that is your answer up there. So I hope that helped you. Let me highlight these. It really depends on the sign of this. That'll be the first part of your answer. Then the sign of this. Alright, that'll be the middle part of your answer. And the sign of this one right here is going to be the sign of that one. So whenever you're dividing at each step, like you start off saying how many times does x go into x cubed, that's the first part of your answer. It should be positive usually. And then once you change signs and add or subtract is the same thing, whatever the sign of this is going to be the sign of the next part of your answer. Alright, I hope that helped.